Hey everybody, it's Ripley again. Okay, we know how to take derivatives of products, quotients, e to the x. We got all those good things. We know how to take derivatives of sums and differences and all those things. But now we need to start getting more involved with other functions. So by the end of the day, I'm going to show you how to take the derivatives of all 6 trig functions. Now, we've played around with these things in the past, okay? However, we're going to write some stuff up. Now, it's going to get a lot easier to prove these down the road, but we can do these geometrically if we wanted to, but you've seen these before. So the limit as x goes to 0 of sine x over x equals 1. That was one of the first limits that I ever showed you back in pre-calculus. And, excuse me, the limit as x goes to 0 of cosine x minus 1 over x equals 0. Now we played around with this. We'll prove this down the road. We want something called L'Hopital's here for down the road. But that said, these two limits are really good limits for us to be able to take the derivatives of the trigs. Now here's what I'm going to do. If f of x equals sine of x, I want to know what f prime of x is. That's what I want to know. Now, just like every other derivative that we've ever taken, unless it just built on something that we already knew, we have to build it the same way. So f prime of x, the only way to build a general derivative is by taking the limit as h goes to 0 of sine of x plus h minus sine of x all over h. If I stick 0 in the top, I get sine x minus x, sine x, excuse me, over 0, 0 over 0, boom. So my first trick, if I've got to do some algebra, is I'm going to use the sum and difference on this guy. Okay, so this is going to end up equaling the limit as x goes to 0 of, now remember the sum and difference for, I'm going to run out of room here. And you know what, let me drop down, give myself just a little bit more space. This is the limit as h goes to 0 of, now remember how this worked? It's sine x cosine of h plus cos x sine of h minus sine of x. The whole thing is going to be over h. Now, I'm going to put these two guys to work. I'm going to see if I can find a cos, now notice, these are x's. So if I can find myself a limit as h goes to 0 of cos h minus 1 over h, well, there's a cos h. Maybe I can, oh, wait a sec. Hey, look at this. If I take the limit as h goes to 0, I'm not even doing anything fancy. I'm just using my commutative property of addition. Doesn't this become sine x cos h minus sine x plus cosine of x sine of h? Now, I'm going to write this as a common denominator so you can sort of see why I did what I did. Now, looky here. If I factor out a sine of x, don't I get this guy? And this, look at this. This is just in perfect order right here for this guy. So if I come up here, look at what happens. The limit of a sum is the sum of the limits. So the limit as h goes to 0 of, now I'm going to factor out a sine of x. Now remember, as far as h is concerned, sine of x is just a constant. It's along for the ride. Okay? So this is cos h minus 1 all over h plus the limit as h goes to 0 of cos x times sine of h over h. Hey, the limit of a product is the product of the limits. Remember, sine x is just a constant because we're talking about h. It doesn't even see that x. So this ends up being sine of x, put equal signs here, times 0 plus cosine of x times 1. Guess what the derivative, of sine of x is? The derivative of sine of x is equal to cosine of x. Awesome. Now, similarly, I can employ the exact same tricks if I needed to. Let's see if we need to. You ready? How about we find the derivative of cosine of x? Well, we know that's going to be the limit as h goes to 0 of cosine of x plus h minus cosine of x all over h. This equals the limit as h goes to 0 of, well, remember this guy? This ends up being cosine x cosine h minus sine x sine h minus cosine of x all over h. All right, now here we go. Let's see. I'm gonna gather some terms because I want to try to employ these guys again. H goes to 0, so this is going to be cos x cos h minus cos x minus sine x sine h. Whole thing is over h. Now look, if I factor out a cos x, I get the limit as h goes to 0 of cosine of x times cos h minus 1. Look at that. All over h. Hey. We're going to get to use that guy. Minus the limit as h goes to 0 of sine x sine h all over h. Just common denominator, right? Respect thy negative. God been a mathematician. Now we know what this is going to turn into. This is going to turn into cos x times 0 minus sine x times 1. Guess what? Awesome. Hey, guess what? We just got the two biggest biggies in the whole wide world. I know that d over dx of sine x, now free of charge, is equal to cosine of x. I know that the derivative of cosine of x equals negative sine of x. Now, you may say, Ripley, are you really going to force us to do this whole limit as h goes to 0 thing for tan of x? Absolutely not, because I know this is exactly the same thing as the derivative of sine x over cosine of x. Now watch what happens. This is a quotient. Low d high, right? Low d high. Derivative of top is cosine. So I'm going to end up with cosine squared x minus high d low. The derivative of cosine is negative sine, so I end up with plus, whoa, I end up with plus, God dang it, plus cosine squared x all over low squared, right? So let's see, cosine squared x, right? All right. Well, what just happened there? Wait, I know. Wait, what the heck did just happen? Try this again. Minus, I'm looking at this going, wait, that's not right. Let's try it again. Low d high gives me this, minus high d low. D low is negative sine, so it's going to be plus sine squared x. I don't know where that other cos squared came from. And here's where I'm at. Now, look, notice no limits required, which is fabulous because I know that tan is sine over cos. So cos squared plus sine squared, last I checked, from my trig days is 1 over cos squared x. And guess what I get? The derivative of tangent x is secant squared x. Ooh, let's do it again. How about the derivative of secant x? That looks like fun. Well, again, I know that secant, this is exactly the same as just 1 over cosine of x, right? Now watch, low d high. So that's going to be 0 because the derivative of a constant is 0, minus high 1 times cosine of x, which is negative sine of x. That remember up here, those are going to have to be memorized, you guys. Unfortunately, you know me. I don't ask you to memorize much, but the stuff I ask you to memorize, you definitely have to. Okay? All right, all over low squared, which is cosine squared x. Those negatives cancel, and I end up with sine x over cos squared x. Now, problem is, that's ugly, and I can actually cheat a little bit. Look at this. This is cos squared. So sine x, can't I rewrite this as sine x over cos x times 1 over cos x? And guess what that is? That's secant x times tangent x. Oh, it's awesome, isn't it? So the derivative of secant x is secant x tangent x. Let's keep doing it. Let's let it ride. I'm going to get a little faster, though, right? This is cosecant x, right, which I know is the derivative of 1 over sine of x. I'm just using my product rule because I don't want to have to. I'd rather pull my teeth out than try and use the limits on these guys, especially if I don't have to. There's no rule that says that you always have to use limits. But If you have to take a derivative and there's no quickie little cheaty thingy like I got going here, then you're screwed. So low d high is going to be 0 because the derivative of the top is 0, minus high d low, which is cosine of x, divided by low squared. Now, I'm going to use exactly the same trick, except I know that cosine over sine is cotan, and 1 over sine is cosecant. And I've got this negative floating along. So this is just negative cosecant x, cotangent x. Isn't that fun? Nothing to it. Last but not least, I swear to God, I told you guys, if I'm let's go cotan x, which this is going to be a really, really quick section. There's nothing to it. This is going to be the derivative of, and this is going to be what? Cosine x over sine x, which is low d high, right? So it's going to be negative sine x times sine x. In other words, negative is along for the ride because of the cosine, the derivative of cosine, minus high d low, which is going to be, high d low is just going to be cosine x times cosine x. And this is going to be all over sine squared x. Now notice this negative, that's going to be really important. This ends up being negative sine squared x plus cos squared x. Oh, and life is so good. All over sine squared x, which is negative 1 over sine squared x, which is, guess what? Negative cosecant squared x. See how they're all intertwined? They all end up looking very similar. Derivative of sine is cos, derivative of cos is negative sine, derivative of tan is secant squared, derivative of cotan is negative cosecant squared, derivative of secant is secant tan, derivative of cosecant is negative cosecant cotan. See, they're all intertwined in there. But remember, like in class tomorrow, what if I throw something like this at you? What if I do e to the x tan x minus x to the 5th sine x? All right? If I want to take its derivative, well, I got to be real careful. This is a product. This is a product. So I have to look at that as such. The product rule says the derivative of the first times the second as it stands plus, so think of it like that, I'm just taking the derivative of that, plus the derivative of the second, which is just secant squared x, times the first as it stands. That takes care of the first term. Next one, the derivative of the first is 5x to the 4th times the second as it stands, plus the derivative of the second, which is cosine x, times the first as it stands. Go slow. Take deep breaths. It's real easy to make stupid errors around these if you're not real careful. And this is really, by and large, I mean, I guess you could factor out an e to the x, and out of these terms you could factor out an x to the 4th, but by and large the derivative is taken. All right? Hope you enjoyed that. We'll play a lot more with these tomorrow. Just remember, every one of these sections I'm just adding new derivatives on top of. Okay, I'm just stacking a new derivative. That doesn't mean that you get to ignore the last set of derivatives. That means that you're just going to have more stuff to keep track of. All right? The easiest way, make flashcards, man. I would just make flashcards. Treat it like a vocab thing. Okay? We'll see you in class. Have a